I have it open again.
All right. Can you speak, Jake?
Hey, I can speak. Okay, I think we're live. I think we've done this.
It works.
It works.
We're live. We are extra specially live. This should be some good fun, guys.
Yeah.
I say good fun. Fun for you. Vaguely hilarious, maybe vaguely troubling for us. We'll see how we go.
We'll see how we go. So, also, someone just followed us 5 minutes before we started, so shout out
Also,
to AZ
the stream name is very wrong as well.
Oh shit, is it?
Yeah, it's still
Let me
set
see if
to-
I can do something about that without stopping and restarting the stream. We're not playing with Debian. We are reversing
What happened was, I love a good what happened was.
old stuff.
Jacob's using vanilla OBS, whereas I use Streamlabs. And I don't know if vanilla OBS... Does it let you set the stream info?
Yeah, it does. Looks like it does. So, yeah, I realised about an hour before we started that I had literally nothing installed because I've wiped my laptop since we last streamed. So, we've been in a bit of a mad rush trying to figure out what we're going to stream and also set my laptop back up for streaming. Hey, Mark.
It's Morky.
Okay,
The
that
Morkster,
stuff should
Morkmeister.
all be good now.
Yeah, it's been a bit of a... So last week we did a kind of start to set up a Debian baseline. For those of you playing along at home, my issue with Python was I didn't restart again, so I fixed that.
Also, I did not take the time to set up my Debian completely, so for this stream we're going to be using pretty much stock standard Kali because that was a lot easier to get working for reverse engineering than figuring out what was missing and installing a bunch of shit on a clean Debian.
However, again, for those following along at home, I can't talk tonight. I did get it working on Debian, so
Nice.
you know. I mean, it's not that hard. It's
not hard. It was just one less thing to stress about.
There's Ghidra is one of the tools we're using, and to get Ghidra working, I just had to install Java. I use
Java.
Amazon. I use Amazon or Amazon. I love it when people say Amazon. Amazon Corretto. No, I just said Amazon. Fire. Stop saying it. Stop saying it, Reese. Yeah. There's OpenJDK, which I can find is a bit touchy, and then there's Oracle's Java, but to install that, oh gosh, the amount of nag screens you have to go through. So I'm not about that.
Yeah, I don't think anyone's about that.
No, I just use Amazon Corretto, and that seems to work. So, yay.
Yeah, I'm pretty sure that should flick over to my monitor.
Any luck.
Kali on it. Sweet.
And so today we are doing one of the retired reversing challenges from Hack the Box.
Yes, so Hack the Box has a bunch of different CTFs, not only CTF VMs, it's got challenges as well. And one of the challenges that we had a write-up for a couple of years ago and then we're just waiting for it to retire was a challenge called Find the Secret Flag. And now it's well and truly been retired, so we can do our run-through. Yay.
Very nice. Yeah, 2017.
Yeah.
That was when it was created.
Yeah, it was created in 2017. We did it in 2019, and sometime between 2019 and now, it got retired. So pretty much, yeah, go download it if you want to follow along, but you also don't have to. When you get it, you get a zip. You just unzip it, and we should end up with a binary called secretflag.bin. Easy. Taking a quick look, so when we do some reversing stuff, we start with, kind of like when we're doing a CTF, we start with a bit of enumeration, if you like. So we do things like the strings command, which we sort of talked about. That's a different challenge. Yeah, sort of like we talked about last week with
strings of like or bytes that are in like the ASCII character ranges or Unicode character ranges.
Yeah.
Yeah. So you do see some garbage in.
So we can see that it's listing a bunch of garbage and a bunch of potentially interesting things, but we don't really know how they're used in the app or what they're used for. So the next thing we can do is try and just run the app and see what happens. Actually, I need to... just ignore that. So we try and run the app and nothing happens. And we're not sure why nothing happens because we don't know what any of the code in the background is trying to do. A quick and easy way to see what the app's trying to do is to use like a tracing tool or something like that. Rather than going into full debug mode, we can just see what's going on in the background. And for that, we use a tool called ltrace.
I should actually say before we jump ahead too far,
okay,
you do have to make the executable executable.
Oh yeah, okay.
Yeah. That's just chmod
so
777.
Yeah, well 755 777 doesn't really matter. Whatever gives it the whatever gives it the little X, that's what we want to see. Hey Kiwi, just in time for us to start. Yeah, so anyway, so we've got the binary, we've made it executable, we've tried to run it and we can see that nothing happens. So we use a tool called ltrace, which does prints a bunch of tracing info in the background, and we can see that the app does some stuff, creates some randoms, and then tries to open a file on the local system. And that file currently doesn't exist. If I... what's the worst that can happen?
Specifically what ltrace does is when it sees a call to a library, it'll basically just print out the information about that call. So the call and any data passed to it, which is why you see when Jacob runs it, or you see that stuff.
Or this stuff. So yeah, it's kind of showing you all the calls that it makes, and it tries to open this file and then it instantly exits. And that's why when we run the app, nothing happens, because it looks for a file, the file's not there, so it just quits. So what we're going to do is touch that file so that it now exists. And come on, run ltrace again. This time we get a little bit further, so it opens the file exists, it does some memory setting stuff, and then it does a string compare. And it string compares with a very super secret key. The string compare is comparing something that's empty with the very super secret key, and we haven't had a chance to input any user data. So that kind of leads us to believe that it's pulling it from this file. And we can test that pretty easily by doing something like echo test to temp, if I can type, temp secret. So now if we ltrace again, we see that it is, kind of confirming our suspicion and doing the string compare of whatever's in this file with their very super secret key.
I'll also say, if you call the binary and then put a number after it, you do see some extra stuff show up in ltrace as well. Like, give it an argument. There's a...
Yes.
Yeah. I did notice that when I was mucking around with it a bit earlier.
So we can see it makes a few extra calls when we do that.
Yeah, it's the A2I, which is, oh gosh, I forget what A2I is.
I can't remember what that function
Something
is.
to integer.
Argument to integer, probably, A2I. Let's go with that. That makes sense.
No, I'm googling it. I'm googling it.
Anyway, so we're going to ignore that for now because we haven't got that far. So now we know that it's doing a string compare with whatever's in this file with this string here. So we're going to do exactly the same thing, but this time we do a -n because we see that we get this little new line character and we don't want that. So
it does. It converts a string to an integer.
Oh, it does? Okay.
Yeah.
Not an argument. So
yeah. But it does say argument to integer, which I guess comes from the C days when the arguments
ASCII
were
to int. There you go.
Something like that.
Someone
Whatever
knows
it is.
their old school coding functions. Yeah, so we use the -n because we don't want that new line character, because otherwise the string compare won't work. And then we run it again. And nothing happens. So we can see that the app pretty much doesn't do a whole lot of stuff. And like you said, we can run it again with some arguments, and no matter how many arguments we give it, it just does the single A to I and still does exactly the same stuff. So now we're finally getting to the point where there's not a lot we can do just by running the app and looking at what it does and what it calls. So we have to actually start reversing it. And this is where we get into Ghidra. So Ghidra was a tool that the NSA released a few years ago.
Yeah, it still feels new, but yeah, it's actually a couple of years old now. It was,
yeah. I mean, I feel like, well, we were using it at least in 2019. So 2018, 2019-ish, they released it. Yeah, it doesn't matter. Let's just create a new project for the hell of it and call it stream. Yay. So when we open our little project that we just created, come on, it's Java, so you got to give it some time.
Should also clarify, we are not Ghidra experts.
No.
We functionally know how to get to where we need to.
We know how to use it vaguely to do what we need to do, and that's it. We don't necessarily know everything about it. So we do know that what we want to do. Sorry.
If any of you out there are power users, feel free to let us know.
Yeah. Feel free to let us know if there's a better way of doing what we're doing. So Ghidra's done a bunch of magic for us to figure out that it's a Linux binary and what language and compile and everything it was written in. So, yeah, those were words.
Back in the day, in our original notes, there was a bug with this particular format, or just this process, and so you had to choose raw binary. But
yeah, you had to choose raw and select the language correctly yourself, because there was a bug that basically made it so that we couldn't patch stuff, which is what we need to do later. So for this, we're going to say yes, we want to analyze everything, because at the moment it's all just a bunch of kind of garbage. I do select all because why not? What's the worst that can happen? And in the background, we can see it's doing a bunch of things and decompiling everything in the app. Lucky for us, it's not a big app, so it decompiles pretty quick. Okay, I guess a quick Ghidra run through of the UI. We've got the program tree, which we pretty much never look at. We've got our listing, which is kind of our entire memory stack for the program. And then we've got our decompiler window. Yeah, exactly. Just YOLO into it. What's the worst that can happen?
Yeah.
And then the one that we care about is the symbol tree. So in the symbols, this is where all of our actual decompiled stuff is. So we've got, if there's any classes, functions, imports, exports, all that kind of stuff. And
this is where it's happened to find interesting things.
Yeah.
That's all. Labels, functions. Well, I say functions. It's all assembly, but where it finds functions, I guess, for lack of a better word, whatever other garbage is in there, that the decompiler, I guess you could say, is just labeled stuff.
Yeah, so it labels stuff arbitrarily so that it makes sense and can link it all internally. There are better decompilers that can give it more reasonable or human-friendly names, but we don't really care that much. So in here, we look for the entry function. So the entry, if you know anything about programming, that's like the main function or something like that. It's kind of the first function that gets called when you run the app. And we can see in here that when we first run the app, it does a start main and it calls this function. So if we double click that function, well, we don't really know that this is what it fully calls yet, but this is one of the parameters of the main function that we're calling. So in here, we can take a quick look, and if we go back to our ltrace here, we can see that before we actually get into anything juicy like the string compare or the fopen or anything like that, it does some timing stuff, it does some random functions, and then it does the ASCII to int. And a lot of that is in this function here. So we've got the random string,
the time,
we've
got the time above it.
Yeah, we've got the time, the random. If there's a parameter, we start to do that A to I stuff, and then we call something else. And looking at this function, this is where we can see that we actually start to get into something cool. So local 10 is our open file, and it's comparing it to whatever that does. Set some memory.
That's if the file's null. If there's no
so that would be if the file doesn't exist. If when it does the fopen, this becomes null, then we just exit, and that's kind of what we were seeing. Yeah, null file handle. Man, see, we're getting taught by our chat. That's fine. Then we've got our string compare. So basically, we're reading our local file, which is our open file, into this variable local78, and in the next line we're comparing local78 with that string very super secret key, which is actually, that's a pointer to the memory address that's holding that very super secret key. That's just the naming convention Gidra's given it.
If you hover over it in Gidra, you get a handy tooltip kind of thing.
So you can tooltip it, or you can double click it to see it in the stack, and we can see that this memory address here is holding the string very super secret key. If they don't match, we quit. If this is a bunch of hex values that I don't know what they are, I don't know what those hex values mean, but if that happens, then it returns a 1, otherwise it returns 0. I think what that means is we can actually set the value of the file to be those hex characters.
Yeah, they're characters.
Yeah. So
that string compare.
Not that.
Yeah, we don't want that string compare to evaluate, I think. No, wait, if it equals to 0, we do want it to.
I think we want it to evaluate to this. So we do...
Yeah.
I don't know if we need the slashes, the escapes in this.
So actually, a brief, quick, I don't know if there's anyone watching who this might be helpful for, but a brief, quick refresher. When you write something, and presumably this was written in C, and you compile it, the compiler takes whatever you write in C, all your nice function names and variable names, and I mean, C's still pretty basic compared to newer languages. You compile it, it gets compiled down to assembly, which is then, well, actually, I say it gets compiled down to assembly. It actually gets compiled down to a whole bunch of binary machine instructions, which the CPU reads. You can go and Google the simplistic view of how a CPU works. However, those simplistic views are like how CPUs worked in 1978. They're a lot more complicated, but it's so abstracted from us, it kind of still works. Yeah. What was their name? Spectre and Ghost. 2 examples of how modern CPUs work nothing like they did 40 years ago, or even 30, 35 years ago. Yeah, 40 years ago, that works. My maths checks out. And so... what something like a this is doing is two phases in the
Let me unpick
assembly. In the assembly view, what we've got is it parsing each instruction bit by bit and basically breaking it down for you. I think not years ago, last year, we might have started to write a disassembler that could basically chew through each byte of the binary and tell you what it was doing.
Yeah,
Yeah,
I remember doing
I
that.
think that might be partially on GitHub. I can't remember.
I can't remember where we put it either.
And then the smarts to change that assembly into the C that would compile it. However, because we lose all the we don't have the debugging logos and stuff like debugging symbols and stuff like that. We don't have any of those, so we don't know what the variable names actually are, which is why we get ivar1 and local 78 and local 77. Presumably, the locals refer to variables local to that particular function. So it's all a bit crazy with C. I say crazy compared to more modern languages, which take away a lot of the pain. C, it's all there.
Okay, never mind. So I remember where I got this value from now. So I'm just reading the write-up going, wait, I've just got stick this in the secret file, but I can't remember where it came from, but now I can. So
your note-taking is great.
Yeah, my note-taking is amazing. So look,
I feel so rusty though, man.
So we're doing a string compare here with something to these local variables, and these local variables don't get assigned in this function anywhere. So if we click on them, we can see that they actually are these hex values, and that's the hex values that I need to put in the secret file.
I may have been completely wrong about presumably the local variables get defined in that function.
They can, but they don't always, I think. I think it depends on the language. So these might be like global variables that happen to be used in this function. Like, I don't know, it depends on how Ghidra decompiles globals. That's my assumption anyway. So we've got 0xDE, 0xAD, 0xBE, and 0xEF. And they're basically just coming from here where we've got our local variables. When we click on them, it's showing that that's DE, AD, BE, EF. So this time we dump that in here and do another ltrace without all the garbage.
Good old dead beef.
Good old dead beef. And I don't think anything else different actually happens. Very simply say return 0, whereas that returns a 1. That doesn't return 1, that returns 0, and very super. Okay, so my write-up has things the wrong way around. That returns a 1, and that returns a 0.
This is the part of the stream where you get to feel the sheer quality that we exude.
Yeah.
It's been a while, and the reality of like the work we do is you're not really dealing with reverse engineering stuff written in C.
No.
Most of the time it's pen testing web apps.
Yes.
Or engineering cloud solutions. Or reviewing firewall rules.
Yeah, pretty much. So basically what we're figuring out here is that this function returns... Oh, that was the wrong one. Which one was it? This one? No, it wasn't that one. Must have been this one. Nope, wasn't that one. Which one did I click on?
Oh, to get to 4009 AA?
Yeah.
Okay, go back to entry. You've got to go back to the entry function. Yeah, or just look at it there. And double click on the 8FD. Go there. Yeah.
Oh, it was here. Sorry, that's right.
Yeah, that one then calls the next function.
Yeah. So this is what
I remember that.
Yeah.
Yes, WAF. WAF indeed. Presumably you mean web application firewall.
Yay,
They're
WAF
always
fun
fun.
times.
We just implemented some new WAF rules. Why did the app break? Because it decided everything was malicious.
Pretty
Just
much.
don't trust user input to the logical extreme and just block everything.
I think that's a fair
So
call.
we don't trust your credit card number or your payment details. Yeah, there's 998.
Yeah, so the
Double
reason that
zero
we're doing
nine.
all of this is because we want it to return either, well, we want to decide whether it returns a 1 or a 0. And doing that will assign us that value to this variable here. And this gets
Yeah.
called here, so as long as it doesn't equal 0, we then get to call this function here. So we don't in fact want this to read very super secret key. We want it to read dead beef so that this function returns 1 instead of 0. And that's what
right.
I've failed miserably to add to the write-up.
Yes. Now we need to just remember how to. Now you get to watch and learn how inept we can be.
Yes. Yep.
So we need to alter the value of that thing, the pointer.
The secret, yeah. So now that it reads that. And now this... Oh, no, that's not what I was talking about. Returns a 0, that returns a 1. Is that supposed to return a 1? Shit, why am I
what are you doing,
so
Jake?
bad?
Oh, this is... We've just walked into fail territory.
Nah, okay. We got this.
Yeah, that's good.
They are no different. Yeah, they're no different. Okay, I'm going to assume that's worked. So now we're assuming that this is 1, which means that we're going to get into this. Yeah, that's right. Sad trombone. Bump, bump. Womp. Now it's time to look at whatever this function does, because we're going to assume that we call it. So reading through this is where we think that we're getting... well, we should have at least something printed to the screen. Which we don't have yet, but that's fine. Oh shit, we should have something written to the screen, hey? Oh no, we could be hitting this where we exit. That's fine. We're on the right track. Let's just say we're on the right track.
It's nothing like assuming you're on the right track.
Yeah, I think we're right. Okay, so this is where the parameter, well, another parameter comes in. So we assign one parameter to this variable, and then we make sure that it doesn't equal whatever this parameter is. And they get passed in through here, which is, I don't know the hotkeys to just go like back to where we were, so I'm going the long way around. One of these parameters passed in is the call to... No, that's not right. What's that? Man, where's local 9? Local 9 comes from here. This is the fun times of decompiling and reverse engineering, is we got to see where shit comes from. So, local 9 is some variable which is just a single byte, and it gets assigned there if there's more than one parameter to the A to I, which the ASCII to int of whatever our passed in parameter was. No, that gets passed in from here, which comes from back up in our entry point. Cool. Does that make sense to everyone? Yay! Yeah, we're all good? Cool.
I'm assuming we are.
Yeah, so pretty much when we give the app a parameter, it makes a bunch of extra calls, which sets a bunch of extra variables, which we end up using down here if we make this function return anything but 0. So, what we did after this... What do you mean that just looks better as the final input? Oh, my notes are terrible.
Sweary Jacob is fun.
Swearing at 2019 Jacob, that's what I'm doing. That's not even this function. var2 data, no, that's the wrong function again. So we want the one that is maybe this one. Nope, not that one. Not that one. This one. But where does that get called from? Sorry, I'm just trying to play catch up because all I've written in my notes is that I need to modify this function, but there's no indicator of where this function came from. So, look at the code in the next function in the stack. We see a similar but different function. Oh, okay. So we just noticed that this one is below this one. So we're calling this function, but below this function in the stack, but not being called, is this function here. So we want to patch the app so that it calls this function. That's what I'm trying to say in words that make no sense.
Yeah, this is the problem when you're doing stuff like this, is you just start going with the function, with the other function, calls this function. It gets very abstract very quick.
Yep. Yeah, it does. Okay, so not here. Not here. Screw it, I'm just going to go back to the entry point and find it. Okay, so here. Instead of calling this function here, which is this one that we know about, we're going to patch this instruction so that it calls this function instead. Because when we look at the stack, what this function actually does is print the actual flag. Not this function which says, are you sure that it's the right one? And to do that, we go here and okay, it just says right click patch instruction. It doesn't say where, and it's not there. It's probably over here. Patch instruction, there we go. Ooh, it got a gold rating. Nice. We should rarely encounter an error. Let's see what happens.
Now we wait.
So we just wait, and what this is doing in the background is pretty much getting ready to recompile the app after we've changed this value. And we want to call the function called 00f400afe. So we just got to replace those two with fe. Easy peasy. Hit enter. Did that just change that by a lot? Or is that showing the... No.
No, that's... yeah. That should be fine.
I don't know if that's fine. Can I Control Z? Oh, I can. Okay, sorry. Hang on. Something changed that I wasn't ready to change. Hello? Entry?
Yeah. Oh, did you broke it? Oh, you broke
I
it.
think I broke it.
Oh, no.
Oh, boy. Okay, that's alright. We'll just do this again quickly.
I just changed the destination
Call
file.
it secret flag 2. Go. Yes. Analyze. I need another sad trombone because I fucked something up. Alright. So we're back at the entry point. Back at this function. Yeah, see, because 8FD has all of this stuff.
Yeah.
And when I patched this,
AFE.
okay. You're not going to patch it this time? Have a cookie. Nom nom. Cookies are nice.
Okay, what happens?
Oh, okay, hang on. So I'm not going to do that. How the fuck did I do that last time? Okay, so I changed this to FE. That didn't actually change anything there. Okay, that's fine. Never mind. The screenshot I have has 2 knops in between, but that could just be
Depending
Gidra
on how
doing some
the...
magic compression stuff. That's fine. Okay,
Yeah.
never mind. Everything's good this time.
All right.
Oh no, I know why it's not good. Because we patched something else as well. Where's that? Did I patch that in? So in the screenshot, sorry, just so that people that can't even see what's going on. When I patched it, it's basically passing local 9 in as both parameters.
Yeah.
But there's no instructions on how I did that. So let's run through this together. Yay!
Hopefully through us learning, you learn.
We've got the byte pointer to EAX and local 9. Go away. This one. I need to patch this one as well. Yeah, so this one needs to be patched to... Ooh, we still want to move, and it's case sensitive. Come on, catch up. I typed. To RSI. Oh fuck, it didn't like that, did it? That to that, that to that, that to that, and then make... Can I patch these into knobs?
9AA.
There we go. Now we're all fixed again. So... Now, I can't remember what these mean, but I used to know. But basically, they're just moving some pointers around on the stack to make it so that what we're passing into this function is essentially the same thing both times. What does this function even do? It only takes 1 parameter. Yeah, I'm sure it doesn't matter. I did it in the write-up, so I'm sure it works now. So we're going to Control S to save that, and now what we have to actually do, because we've patched the file, we need to export it. And when we export it, we are going to export it as a compiled binary to /root secret flag 2. Sure, that sounds about right. Let's do that. Okay. We good, Gidra? You going to give me any indicator that you did something? No. Okay, sure. We need to chmod this. I just use 755 because it's easier. And when we run it, we get a seg fault, which means it failed. Yay! Ah, shit. Okay, that's fine. We're calling that. That looks good. That all looks fine. I mean, we could probably... Oh, hey. Thanks for the referral, show. So I don't know why we're getting a seg fault now. Probably because... I mean, that does look exactly like the write-up. No, I don't want to start again. But I think we fucked it.
No. Uh-oh. I think I did too in my run through. Oh, the joys of remembering how you did stuff years ago. Yeah, 8FD. Wow, 8FD is very different now. I messed that up.
Yeah, you patch the instruction to update it to look like that, which I did. And now... That's right, that's right. That's right, that's right, the knobs are right. And then that should be it. Shit. Can we L-trace it to see where it's breaking? Oh, it's not called that anymore. What do we call it? 2. Okay, that's not right. It could just be the export was wrong.
Didn't it say it was gold? It was gold standard.
It said it was a gold standard, yeah. It shouldn't have any errors exporting it.
I don't have a clue what gold standard means.
Neither. Yeah, save and export as binary to something like secret flag patched. That's the raw thing that it says in my notes. Yeah, so it's none of those. It's got to be a binary. What have I done wrong? This is super entertaining for anyone just tuning in. Sorry that you tuned in right at the time that we fucked everything up. And now we got to try and figure out what we're doing. This is always the worst part of the stream for us when we're unprepared. Cool, let's try again. Number 3. Yeah, I'd blame show as well, to be fair.
No, I don't know. I wouldn't
No, it's not show's fault.
blame him by default. I mean,
Yeah,
it takes many people to tango.
this is true.
Oh, jeez. For some reason, Gordon Ramsay yelling at people in like a kitchen just came to mind. That's what he'd be doing to us now if he worked in infosec.
Yeah, it's obvious what you're doing.
What are you? Are you a bloody donkey for brains? I don't. That's not how he talks at all.
What is it? Like, you're an idiot sandwich. That's the meme, isn't it?
Yeah. You're an idiot sandwich. Oh, jeez. Infosec needs a Gordon Ramsay. Come on. Someone come forward.
I think that's a bit harsh. He's not being dumb. We're the ones being dumb.
Okay.
Like, how does mine look so much different now when I do the exact same thing? Because we basically just want it to call that function, don't we? I mean, we could probably patch it in a bunch of different ways. I don't think this has a non-light mode option. To be honest, I've never looked at the... Oh, it's not there.
So, you know, in
Preferences?
009AA...
I don't think there's an option for dark mode in Kidra. I wish there was, actually, because it's quite hard to read. Yeah, I'll do it in front of the stream.
Compare.
There we go. Then they get the...
Yeah, okay. I think I might have ghettoed it.
web browser.
I've got that to return. That's returning 1.
Yeah. They don't want to
So if I
save
go back
power
up.
or people's health or anything like that. Whoa, that's a bad type.
So now that returns 1, we run that.
Oh, look, someone's built a dark theme for it. No. I'm just getting distracted because I don't want to go back to this because I broke it too much. Okay, so what are you doing? Are you just patching this to always return 1? Is that what you said? Okay.
Yeah, I've ghettoed that to just return 1.
Okay, cool. So now that will return 1 no matter what we do.
Yeah. So as long as the file contains very stupid secret key.
Yeah, it'll always return 1.
Yeah. So a lot of this is really just figuring out your intended control flow path. And then it's almost like living off the land, but inside an executable. You've got to work with kind of pre-existing logic that's there, otherwise you end up just munting it all too much.
So we're going off script and not following my stupid write-up from 2019.
Yeah.
So now that'll always return 1, which means back up here, we will always call this function, which is cool. But we don't always want to call this function, we want to call function fe. So we're going to patch this as well to also call fe. And I'm not going to change anything else and just see if we can export it as a program that runs and doesn't segfault.
That's always the key. Not segfaulting is pretty critical.
Yeah, that's it. 2019 me is sad that I don't trust his writer. Oh, man. I know, at the time, this would have made perfect sense and gone flawlessly. But now, I have no idea. Oh yeah, that exported as secret flag 3.
Oh,
cool.
Gosh.
That's right, it exports that, but we want 3, and then we run secret flag 3. Ooh, not 4.
It exports like to your home folder by default.
It segfaults too.
Not pay attention to. Half a sec.
Yeah, but mine segfaults still anyway, so it's still broken.
Yeah, secret flag 2.bin.
Man, I wish I had kept it because I could have just referenced back to it and decompiled my patched one. Note to future self: if I have to patch binaries, upload them to the write-up.
Here's one I prepared earlier.
Yeah, here's one I prepared earlier that works.
Yeah, I'm getting invalid section index segfault.
Yeah, I just get segfaults now.
So this is where I might just do a handy Google just to...
RDI. So my stack looks completely different in the screenshot in my write-up. So I'm just going to force the stack to look the same.
That's the way.
So AAX, call lab A8, pointer that, do that, 2 nops, and then call function that. Okay, that's all I've got to go with because that's all I've got in the screenshot. Because I'm good like that. Except it's calling a halt bad data function now, which is not good. Oh, that's just because these aren't nops yet. So we want to patch them to be a nop. And patch that one to be a nop.
When in doubt, nop.
Okay, cool. So, oh, that's not quite right either. That doesn't look the same anymore. Local 9. Where do we use local 9? We pass it down here. Shit, if that equals that, do a bunch of stuff. If it's 0 or 7F.
CVAR is set further up.
I could just make it always... Well, I don't know if I want it to be CVAR or if I want it to be IVAR 2. So... maybe we'll leave that. That should be right, that should be right. Okay. So, let's do a big boy save and try and export it again. Maybe let's dump it somewhere else, like... no, not in there. Let's just go up a level to... oh, really? There. Secret flag patched. Because if I name it the same as I did in the write-up, then it has to work. Yeah, I know. It's an elf. Okay, awesome. Let's see what happens now. That. Not that. So... we called it patched. Oh, secret flag underscore patched. Cool. Now... shit. Okay. What if I give it a parameter? No, it's still broken. Oh boy.
Half a sec.
I think we gone really broke it.
It's great. It was working until it wasn't.
It was working fine until it wasn't. Because I didn't think that this was going to be the bit that it would break on.
Okay, can I delete? Yes. Let's import file. Well, x86 GCC.
So what's our temp secret right now? Very super secret key. Okay, if we take it back to dead beef, does that change anything? I don't think it will. Temp secret. Yeah, I didn't think that would do anything. Okay, we broke it.
Okay.
We should be done by now. Easily done by now.
I'm trying with it as war again because I stumbled across something that referred to that issue might still actually be there.
Oh, is that what the seg fault is? Yeah, okay.
It could be it. So I'll just change my one thing. File, export.
Oh shit, I closed all of Gidra.
Export program. Yeah, that happened to me.
I was like, but... because I followed the link to the GitHub issue, and it said it was closed and fixed, so I just assumed that it would be fine.
I mean, it might be. I'm just...
That's probably what I get.
Yeah, okay.
No one cares what this says. We're going to run this. Okay, we're starting from scratch, but this time we're going to import it as raw like we said, because it could be the only thing that's fucking us over. Import file, it's okay because we've marked the stream as not for kiddies. Okay, this one, the compiler is real. Man, that's so tiny. We want GCC 64-bit, but...
okay, that's
the elf one.
Yes, okay. That works now.
It was that?
Yeah, I'm
That one. That's the one we want.
okay. 0.
Yep, this is what reverse engineering is like.
That reminds me of that meme, you know, that I don't know what the anime show was, but the guy's like looking at a butterfly and he's like, is this a whatever it is? And the meme is this reverse engineering? Except it's a picture of Jake crying.
Pretty much. It's
Um,
me yelling at 2019 me. Yeah, but see, when I do mine as raw, I don't get the functions
yeah,
decompiled properly.
I just went straight to AFD because I remembered the end of the function. So the functions are still all there. You've got 009 and AFD, 8FD. Click on that. That looks very familiar, doesn't it? That's just that function we were looking at before. And line 20 in your
Oh
C,
shit, yeah, it is too.
part
Yeah,
3.
okay. Yeah,
It doesn't have the 4.
It's just
'cause
renamed them differently. Yeah. Oh, good.
Yeah.
So, what do I have to? I have to rename it to AA, I think. Yeah, because that's the next function in the list, which does all of that shit. Yeah, okay. No, that's the one that returns 1 or 0.
Yeah, that's the one that returns 1 or 0.
So I don't want it to be 8AA. I want it to be A5B. No,
Yeah.
I don't even want it to be that one. Do I?
What was it? 8FE? Oh, the one AFE?
AFE. I want it to be the one that prints the value to this console.
Okay, now we've just got to hunt around, but
I think is so, yeah. Well, we kind of made it hard on ourselves by ruining everything.
not documenting it properly, Jake.
Yeah. Well, now we just have to refigure out the function that we're looking for. And I don't think it's any of these weird ones. No, it's none of those. Because we're looking for the one that puts stuff to the console.
What function call are we looking for?
A puts. Like it should puts the are you sure it's the right one and hit any key. So what I'll do is, oh, not that, I want it to be a string. R.
Yeah, it might not have found that as a function.
I don't think it I don't think it set it as a function properly, which is a bit annoying because that's that function. So AA and then this one that we were just in. So that's still just A5B. And in A5B we should see... Oh, okay, so it hasn't called them puts functions because that's supposed to be a puts there. And that's calling that memory address that. Yeah.
Okay, so I think when it's raw, it's not doing all the figuring out all the system stuff.
Yeah.
Yeah.
So it's not actually also decompiling nicely naming the system calls.
Yeah, resolving the references.
Yeah. So we want to patch this one to be, the AFE one.
AFE.
So we want that to call.
And the 2 moves above it to be knobs.
AFE, yeah. Well, I think we still want to change that to RDI RSI. And then we need to make these knobs. And then they should match the write-up. And that should be all we need to do. So we're going to save that and export it again. This time as patched again. Not
And
as
that's
a zip,
because
as a binary.
this is there's a few different ways to pass arguments around an assembly, but normally they're either pulled from a register or from the stack when you jump to a particular function label. That's all the compiler does is, and when you're hand coding it, is by convention knowing where to pick up the parameters from.
Yeah.
Which is why we need to go RDI RSI.
That's all right.
I want to change it to param1 RSI, but we'll see if that works for me. And then NOPs are just to solve the issue where it doesn't know what should go where.
Oh, it's not called that. It's called patched again. Yeah, that's why. Okay,
Please
cool.
work.
We don't get a seg fault anymore, and the app runs. But it doesn't print out. Is that because... Oh, I know why. It's because I need to put dead beef back in my secret file because I didn't do the hard-coded so it always returns one thing.
I did. Okay, I will also try and patch out my export mine and see if it works.
So now if I run this...
The Chinese are the most powerful people in reverse engineering. Is this true? I don't personally know if it's true, but I think like most nations, they probably have people who are experts in such things.
Yeah.
Did that work the way it was intended to, Jake?
Nope. It's supposed to print this function. It's supposed to print the are you the right... No, it's supposed to print hit any key. No matter what I dump in here, it's supposed to print hit any key. Okay, cool. What that means is we go into 9AA and we update this to always return 1. Save it. Export it as, let's call it secret flag 2. We're not segfaulting though, so that's something. Chmod 755 secret flag 2 secret flag 2 underscore 2. There we go. Okay, nice. So we had to do the force it to equal 1 as well. We're back on track.
Don't worry, it's not working for me.
Okay, we're only like an hour behind, but it's fine. So, just a quick recap of what we did because I don't know how many people actually followed that. Over here, we've got whatever the output of this function gets assigned to this variable. If this variable is not equal to 0, it will call the function that we just patched in. Our problem was for some reason this was returning 0, so we patched this function to also just always return 1. And now what we're doing is calling this function, which is the one that actually prints the flag. What we've got there is not the flag. We need to do a little bit extra to print the flag out. So if we do something like, looking at this data, it looks a lot like hex. So, sometimes we deal with base 64, sometimes we deal with some other shit. This time we've got some hex data. So to convert that hex data into something ASCII that we can read, we pipe it all out to XXD. What the R and P are, I can't remember, and I didn't put it in the write-up. And hopefully this works. Hello?
Yeah. Oh wow, it's taking its sweet time.
Okay. That's not quite the output I was expecting, but it's something. If we had to 1v1 you in an IRL battle royale, who would win? Probably you. because I don't know anything about you.
No, he's if we had to 1v1
Oh, if
in a
we
battle
had to,
royale.
as in you and me. Man, I don't know.
Trying to figure out who.
Probably you.
Check out it. No, probably you. Exercise is not something I do regularly, so. Depends on the battle royale. If it was like a guitar solo battle royale, mate, I'd be all over that. Why?
Okay, so pretty much what's supposed to happen. Hang on, let me just. It doesn't matter. I'll do it in a new tab. That'll do. So when we run Secret Flag 2, we are expecting this output to be the flag, and we notice that it changes all the time. And that's because back in the code when we were looking at it earlier, there's actually all of that stuff that kind of modulos around the parameter that we pass it with that a2 int function.
Right, yeah.
So what we're going to do is just automate calling this app a bunch of times with a bunch of different arguments and hope that the output that we get is the flag. So to do that, we're going to use some Python, and I don't need this, but
Okay, well, what about the two of us then versus Show? I don't know, can Show play guitar? Because if he can, he might be better than me. If he can't play guitar, then I win. That's that simple.
That's it.
I think in your write-up, you were just using a shell for script for this as well. But that's no fun. You want to write some Python?
Yeah. Let's do it in Python. Why not?
You need a semicolon at the end of that format.
Yeah, a semicolon in front of you. So the command we want to run is we want to format string it because we are cool like that. It's called what do I call it? Secret _ flag _ 2, I think.
I would assume so.
We're gonna pass it not 1. We want I, and we're gonna pipe that out to xxd with -r and -p, whatever they do.
That doesn't look like a 2 either.
Oh shit.
Secret _ flag under s.bin.
Yep, 2.bin. There we go.
Yeah. What an adventure. This is just I think we never learned this lesson last time when we were streaming on the reg either. It's just preparation.
That's it. Like, yeah, if I'd prepared and actually tried to follow my own instructions before we started.
Yeah, but then again, we might have tried to change tack and not do this.
Yeah, true. We would have just gone, man, this is too hard.
Demonstrating that sometimes it's like, let's just give it a punt.
Yeah.
Somehow 10 people are willing to watch this, so
man, you guys are persistent, and we thank you a lot for sticking around. I don't think there's any typos in there. What I want to do is an except, if I can spell. And just skip to the next one. What else is there to do in Melbourne on a Monday night? Can't go clubbing.
Like seal clubbing?
Are you guys still in lockdown?
No. No. Yeah, you can go seal clubbing. I mean, it's probably illegal, but no one's going to stop you.
Oh, man. Okay. It's Python 3 automate.py. Oh, shit. What do you mean? Okay, I don't need that line.
Yeah, no, there's a, you need the hash, or the pound, or whatever it's called. You need to comment it. But that's only ever used by the shell, I think, to know what to call.
Yeah.
I never do them.
Okay, so we're running through this 128 times and hoping that one of them outputs
I'm glad
a
yours
flag.
works because mine does not work.
And according to my thing, it was number 88. That's the flag.
88 miles an hour. That's the. Is it 88 miles an hour from
Oh yeah, look at that. 88 has the flag. We did it, boys and ladies, if there's any watching.
Dakota Stefano 118?
And that's our
Well,
flag.
what a rocky road. I was thinking we were going to be like, we were heading towards, I was like, oh, we were done by 8:30, weren't we?
Yeah, I didn't think we'd make it.
So
we
just
did.
to run that back through, we've got a binary. We tried the basics, so strings and L trace, which you're never really going to, outside of the most basic things, you're never really going to find what you're looking for with those. But those can help give you
Yeah,
breadcrumbs or
so
clues.
I mean, the L trace only really would have helped us if literally the code was very super secret key was what all we had to type in, and then we got the flag. But because it
Yeah,
didn't,
a lot of these things they have maths, or I guess you could call it like pseudo encryption. It's not really real encryption, but
yeah.
and you need to give it the right input for a whole bunch of maths to calculate correctly to give you the right output.
Can we run tree, please? I don't know what tree, please is.
I think it might just be a tree.
No, it's not a command. Sorry.
No. Yes.
This is like a
Any-
0% speed run. Yeah.
Yeah. What? No, wait. Any percent. Just run strings on the thing again.
No, just have
Yeah, there we go.
That's
Any
it. The
percent.
trifecta.
We figured out there was very super secret key in there. Done.
Done. That's it. That must be the flag. Yeah.
Unless it's like any percent, like getting the right result. There's for a while there was like a whole bunch of like jazz music. Like there's a guy who what have I forgotten his name? John Coltrane had a song called Giant Steps. There's a whole bunch of like it's for sax players. I think a bunch of sax players, it's considered like a hard song to play, and so it's like playing it as fast as possible. And then there's this whole meme documentary about doing an 80% speed run on that song. Like, how do you do an 80% speed run on a song? But like, you just play two of the notes and go done.
Oh right, okay. It's not about playing it as fast as possible.
Yeah, no, it's I love a good speed run meme. So keep them up.
That's awesome. Yeah, so that's kind of it. What I'll do is go back through my ridiculous notes and do a proper write-up, and we'll stick it on the blog and stuff. And that's it. Thanks for watching.
Yeah, I guess for clarification for new people on, we were streaming originally on Twitch, and then like 2 years ago we switched to YouTube, and then we
we took a bit of a break, and then we came back to scroll down. I see the flag in all caps.
All the way to the bottom.
That
and
one?
then, yeah, we kind of took a break last year with everything that went
Oh,
down.
there.
Not all the way down the bottom.
Do you mean that one?
Or is... Oh. Yeah. It's there as well.
That's still got its hex characters, though.
No. It's Zedbnez Rugden at on.
Oh, that one.
Yeah. Yeah, that's so weird that it's there in all caps as well.
It must be something to do with... Yeah, I mean, the modulo around 88 doesn't make much sense, does it? Because
This is the thing, is I think
on.
this is part of where we were getting to at the beginning of last year, where we stopped streaming, was doing more and more reversing and low-level stuff.
Yeah.
And it's funny how much of it I've forgotten.
Same. Yeah. When we were doing this, I would have been able to tell you what all of the assembly instructions and stuff were doing as well. But just out of practice.
Don't worry, guys. We'll get less crap again.
Next stream, our promise is that we will be a bit more prepared.
Maybe we do still have the commands.
I don't think so, because I banned... One of the last things I did when we moved to YouTube was I banned Nightbot from the channel. So I'm pretty sure there isn't any. Yeah. I will add Nightbot back as well. Also, thanks. I don't know how to say your name, but thanks, Show's friend, for the follow. And also Last Chain, whoever that is. I don't think I saw you in chat, but thanks for the follow.
And we'll be on every week.
Yes.
We'll try for every Monday or Tuesday, which is pretty anti-Twitch good best practices, which is like you need to be on every breathing minute of your life. But
yeah, we have real jobs and games to play, so we do not stream.
Yeah, we don't need to make
8
money
hours a day. Yeah, we're not here to make money. We're just here for fun and to mess around with stuff with you guys and get stuff wrong and you to laugh at us, basically.
Yeah, hopefully you laughed.
1v1 Show in Valorant. Yeah, that's not gonna.
Oh no!
I assume that means that he's actually good at that game.
I expect Show some sort of gaming master.
Is Valorant like a battle royale game, or is it a CS:GO-y type game?
No, it's a battle royale game, I think.
No worries, Kiwi. Hope you learned something. I know that we fucked it up a lot, but normally they're smoother than that when we actually prepare. Well, it's funny. Like I was playing ESO with Kiwi like less than an hour before we had to stream. So.
Oh, it's CS:GO.
Oh, it's CS:GO.
Right.
Okay.
Yeah, I haven't played. I played a little bit of CS:GO, but I was more of like a CS 1.6. If you go all the way back in the day.
Valorant's a new CS:GO game. Yeah. Well, I'd be useless at that. I'm useless at pretty much any FPS games.
Yeah. No, yeah. I don't know. I do whatever. Anyway, see you guys later.
Yeah,
Have a
see
good
ya.
one.
Thanks for coming along. We'll see you next week.
This will be on YouTube if you want to watch our stupidity back.
Yes.
I know I'll be watching our stupidity back.
Oof.
Have a good night. Cheers, guys.
See ya.